Feel your hand. Put it on a wooden table. Now put it on a metal table. Both items are in the same room. They have the same temperature. But your brain tells you the metal is cold, the wood is warm. Why? You think your body is a perfect thermometer. You think you know the exact temperature around you, but that is not true. Your brain is a terrible weather forecaster. It cannot measure the true temperature. It is constantly making mistakes. It does not feel the real temperature. It only feels the speed at which heat leaves your body. For example, metal quickly takes away heat. The brain feels a fast loss of heat, and it yells, "It is cold." Wood poorly conducts heat. The brain does not feel the loss. And it says, "It is warm." This is your first, simplest self-deception. Our hearing, sight, and touch constantly lie to us, but our ability to feel heat and cold is the most broken. We will prove that you do not have a thermometer. You only have an early warning system that often fails. We will uncover 4 main reasons why the brain cannot accurately determine temperature. You do not have a single temperature sensor. Extreme cold can feel like extreme heat. The brain cannot control temperature that changes only on one small part of the body. This is the story of how the body tries to measure invisible energy with outdated and inaccurate sensors. Your brain constantly makes up the temperature, and we will start with the biggest problem. Why your feeling of heat and cold are 2 separate, unrelated systems. Mechanism 1. No single cold receptor. The separate sensors. You think your skin is one big thermometer. It is not. Your skin is a control panel with many different separate sensors. You do not have one universal temperature sensor. You have 2. Cold sensors. They react only to cold. Heat sensors. They react only to heat. These 2 types of sensors are spread unevenly across the skin. It is like scattered surveillance posts across a city map. In some places, they are close together. In other places, there are large blind spots. For instance, there are fewer sensors on your back and limbs than on your face and palms. Important. These sensors do not know how hot or cold the room is. They only know if the temperature is changing at the spot where they are located. When you enter a warm room, the heat sensors activate. The cold sensors are silent. The brain understands it is warm here. But if you stay in the room for a long time, the heat sensors get used to it. They stop sending a signal. This is called thermal adaptation. That is why you stop noticing that the room is warm. The brain says, this is the new normal temperature. The problem is that cold and heat sensors work independently. They do not communicate with each other. It is like 2 different radios that do not listen to each other. The brain is forced to make a decision by looking at 2 incomplete, conflicting reports. Because of this separate operation, the brain is easily tricked. The brain only gets a report on the loss of heat or the gain of heat, but it never gets a report that says, the total temperature is now 70 degrees. This proves that our sense of temperature is not an accurate thermometer. It is an early warning system tuned to changes, not absolute values. Mechanism 2. Phantom sensation. Paradoxical cold. Have you ever touched something extremely cold? For example, metal in freezing weather or dry ice? You feel the cold. But if the cold is too strong, it suddenly changes. It starts to feel like a severe burn. You feel stinging. You feel like it is fire. This is called paradoxical cold. It is one of the biggest failures in your sensory system. At extreme cold, a 3rd type of sensor activates. Pain sensors. Cold sensors scream. Too cold. Pain sensors also scream. System damaged. The brain gets 2 very loud signals at once. It understands that the body is suffering severe harm, but it cannot determine exactly what is causing the pain. It gets confused. The most frequent and fastest cause of severe tissue damage is fire or a hot object. The brain decides that if the pain is this severe, it must be a burn. This is its simplest and fastest conclusion. The brain cannot believe that cold can be that powerful, and it simply chooses the signal it knows best. It interprets extreme cold as extreme heat. This paradox is clear evidence that our sense of temperature is not an accurate thermometer. It is a threat assessment system that often fails when faced with extreme situations. Mechanism 3. Ignoring the gradient. The gradient failure. Why do you not feel the cold on your back? The brain simply ignores it. It is a matter of priority. Your body has one main goal. That goal is survival. To survive, your body must maintain a constant temperature. This is called homeostasis. Your brain always worries about your core temperature. It worries about your vital organs. The back, chest, and abdomen are the core. Hands, feet, and fingers are the periphery. When cold air hits only your back, the cold sensors scream, but the brain receives conflicting messages. Message #on. Back is freezing, urgent. Message #2 core. Heart, liver, blood temperature is stable. No threat. The brain trusts the core. It ignores the complaint from the periphery. It decides it is not a critical signal. It mutes the sound from the sensors on the back. It does this to avoid spending energy fighting local cold. It focuses on maintaining stability. Therefore, you do not feel the cold on your back until the cold begins to threaten the entire system. Until then, your brain simply ignored your back for the sake of saving the whole body. Conclusion: the subjective thermometer. The takeaway: we have seen, your sense of temperature is not an accurate measuring tool. It is a threat assessment system that is constantly being confused. Here are the 3 main errors we have debunked. No single thermometer. You have 2 separate sensors, cold and heat, that work independently. Paradoxical burn. Extreme cold is interpreted as extreme heat by the brain, ignoring the gradient. The brain prioritizes core stability and ignores local cold signals from areas like the back. Your body does not measure temperature. It measures the speed at which heat leaves you. And because different materials conduct heat differently, your sense of temperature will always be subjective. 5 rules for the broken thermometer. If you want to face reality, you need training. Rule 1. Don't trust the quick feeling. When you touch something, do not trust the first feeling. Hold your hand longer. If the item seems immediately cold, it means it is simply good at conducting heat. Rule 2. Always check the center. If you feel the room is cold, do not look at your hands. Touch your chest or stomach. If the core body is warm, the brain is trying to trick you. Rule 3. Separate the sensations. If you feel extreme cold, consciously tell yourself, this is not a burn, this is severe heat loss. This can help the brain interpret the pain signal correctly. Rule 4. Dress strategically. Remember homeostasis. The brain ignores the back. Always protect the core of your body to prevent the brain from ignoring local threats. Rule 5. Admit your body is lying. Understand that the feeling of comfort is not an exact science. It depends on what the brain decided to ignore. Your brain will always be confused when measuring temperature. But now you know how its mistakes work, and you can choose what to believe.